Hi, everyone, and welcome to today's webinar. Thank you so much for joining us. We'll be talking about scoring and data enhancement with the new data pre-processing feature in Linkurious. So before I pass you off to our speakers, I wanted to just mention a couple of things. First, in the Handouts tab on the right-hand side of your screen, you'll find a couple of additional resources on data pre-processing. And second, if you have questions at any point during the webinar, please drop those into the Q&A panel. We'll save some time to answer them at the end. So let's get started. I'm happy to pass you off to Jean and Shraddha.
Hello, everyone. Welcome to the webinar, Scoring and Data Enhancement with Data Pre-processing in Linkurious. I am Shraddha Kothari, Customer Success Manager at Linkurious, and along with me, I have Jean.
Hello, everyone. My name is Jean. I'm one of the co-founders of Linkurious, and I'm very excited by today's webinar.
So to begin with, a little introduction to who we are for the people who don't know us yet. We were founded in 2013, and we have two offices, one in France, headquartered in Paris, and one in USA. We are 50 plus employees, 16 nationalities working at Linkurious, and Linkurious solutions are used worldwide by more than 10,000 analysts and investigators. Here is some sneak peek into some of our prominent clients. We work with around 100 plus clients, and you can see some logos here. Also, we have some strategic partners like Neo4j, Microsoft, Memgraph, Sensing, etc. Let's go on and look at the agenda for today. So today we'll be discussing data enhancement and scoring and how you can do that with Linkurious Enterprise feature, which is called data pre-processing. A little sneak peek into the Graph Analytics toolbox and how you can use it with Linkurious Enterprise, and then we'll go towards demo and use cases. So let's begin. Data enhancement and scoring with Linkurious Enterprise. Data enhancement is the process of improving the quality and relevance of data, making it more usable and valuable for your analysis. There are several reasons why this is critical, and I'll take you through a few key examples. Imagine you have customer names in your dataset, but some names aren't properly capitalized. While this might seem minor, these inconsistencies can impact how your data is being processed or displayed. Enhancing data by standardizing these names ensures consistency and improves overall quality. And often we also encounter situations where the same information appears differently across sources, like country names, for example. For instance, USA in one dataset and United States in another. By normalizing these fields, we ensure consistency, which simplifies analysis and helps system link related data accurately. Let's take a few other examples. Sometimes enhancing data involves adding new context to make it more actionable. For example, let's say you have a list of nationalities and certain ones are associated with higher risk. By adding a risky nationality tag to relevant records, you make it easier for downstream processes like compliance checks for risk scoring to use that information automatically. Lastly, enhanced data makes decision-making faster and more effective. For instance, instead of manually checking a person's transactions one by one, you can compute the total sum automatically. This simple enhancement saves time and enables teams to focus on insights rather than manual tasks. Ultimately, data enhancements transformed raw, inconsistent data into more clean, enriched, and actionable information. This improves the quality of your analysis and allows you to uncover insights. Now let's talk about why data enhancement is so important and how it can impact your decision-making and analysis. There are three key reasons, as you can see here. Increase accuracy. Incomplete, inconsistent, or outdated data can lead to errors, missed opportunities, or even bad decisions. By enhancing data, whether it's fixing errors, filling in gaps, or standardizing formats, you improve its quality and ensure greater accuracy. And as we know, better data leads to better decisions. A lot of time gets wasted on manual time-consuming tasks like fixing data quality issues or even looking up addresses on Google Maps. By automating these processes through data enhancement, you free up valuable time and resources. This allows you and your team to focus on what truly matters, analyzing and making informed decisions. Third one is actually discovering hidden insights, which is the most important part. Enhanced data isn't just cleaner, it's also more powerful. It leverages advanced analysis. You can compute risk scores, detect hidden patterns, identify relationships, communities that might not be obvious at first glance. This takes you beyond simply visualizing data, enabling you to extract deeper insights. And let's go further and see how you can get more out of Linkurious Enterprise with data enhancement. Because data enhancement amplifies your ability to analyze, visualize, and uncover insights, which we've been discussing till now. By enriching your data, like calling an external API to add latitude or longitude coordinates to addresses, for example, you improve its completeness and accuracy, and this opens up new possibilities for analysis, such as mapping location or understanding geographical trends. The next point is better visualization experience, of course. With enhanced data, your visualizations are more insightful. Let's take an example. You can size or color nodes based on a risk score. This makes risky entities stand out visually, allowing you to spot patterns, anomalies, and critical information much faster. With enhanced data, you can also leverage graph algorithms to identify influential individuals or entities or high-risk connections. This enables you to set up smarter, more precise alerts that detect critical events or critical patterns and help you act quickly. Last and finally, data enhancement improves your ability to run powerful queries. For instance, using graph analysis, you can identify people who belong to the same community or uncover hidden relationships. This helps you ask deeper questions and extract meaningful insights from your data. By enhancing your data, you're unlocking the full potential of Linkurious Enterprise, transforming it into a tool that delivers clear visuals, smarter alerts, and deeper actionable insights. When it comes to data enhancement and scoring, graph data presents unique opportunities. Simple rules are easy. Some data enhancement tasks are very straightforward. For example, as you can see here, a rule like if country equals Iran, then mark the property risky country as yes, doesn't require any understanding of connections or relationships. You can just apply this rule with basic logic and traditional tools. But things get more complex when relationships come into play. Take a rule like if there is an indirect connection to a known fraudster, then mark the property connected to fraudster as yes. Computing this kind of rule requires understanding, navigating of relationships or connections across your data. Doing this with a non-graph backend or a traditional query language would be very, very complicated and also inefficient. So that's why you're with graph databases and graph technologies, they are designed specifically to interact with connected data. They allow you to easily traverse relationships even when they are indirect, implement rules and scoring mechanisms that depend on connections, deliver high performance at scale. With graph tools, you're not just enhancing isolated pieces of data, but you're enhancing connected data. And this gives you a deeper understanding of relationships and ultimately makes your analysis more accurate. Now let's move on and see how do you enhance graph data. When it comes to enhancing data for graph analysis, there are a couple of common approaches you could take, but they come with notable limitations. Let's break them down. Traditional ETL. In traditional ETL pipelines, data is enhanced before it's being ingested into the graph. For example, a risk score might be computed using an external machine learning model and then pushed into the graph database. The downside of this approach would be it cannot leverage graph analytics during the enhancement process. You're missing out on the relationships within the graph that could add deeper context or refine those scores. Another approach one could take is custom scripts. Um, built to interact with graph database after the data has been ingested. For example, you might run a graph query to compute page rank using a tool like Jupyter Notebook. And again, the challenge with this is while this works for prototypes or proofs of concepts, it's very hard to operationalize for production workflows. These scripts are often manual, difficult to scale, and lack the automation needed for real world use cases. In short, both approaches fall short when it comes to fully harnessing the power of graph data. One misses the graph insights, and other remains limited to proof of concept stages. This is where the Linkurious data pre-processing feature comes in to bridge this gap, offering both scalability and advanced analysis directly on the graph. Pre-processing data in Linkurious Enterprise is very simple, fast, and automated. Here's how it works. First, you write a graph query to enhance your data. You could compute a property like connected to Fraudster we were discussing, and you define how often you should run this query, whether it's every few minutes, hourly, or daily. Once configured, Linkurious Enterprise will automatically run this query at specified intervals, enhancing your graph data in real time. You go from the graph query to enhanced data in just minutes. No manual intervention, no complex workflows. It's a seamless way to keep your graph updated and enriched. Let's go into a bit more details of this feature, pre-processing in Linkurious Enterprise, and how it makes operationalizing graph analysis easier and more efficient. A pre-processing step allows you to execute graph queries and write the results directly back into the graph. While you still need to develop your graph queries, Linkurious Enterprise simplifies the next step, turning those queries into an ongoing automated process. And pre-processing steps run automatically in the background at a user-defined interval. This ensures new data is continuously enhanced and stays up to date without manual intervention. You can combine multiple pre-processing steps to perform more complex operations like computing risk scores, tagging influential nodes, or detecting connected communities, all in one streamlined workflow. What's even better is that this doesn't require additional tools like GDS, Memgraph MAGE, or AWS Neptune Analytics. Everything runs seamlessly within Linkurious Enterprise. With pre-processing in Linkurious Enterprise, you can quickly operationalize graph queries, automate data enhancement, and ensure your graph stays enriched and ready for analysis. Now that we have seen how pre-processing in Linkurious Enterprise helps automate graph queries, let's take things a step further. For these pre-processing feature, you're not dependent on graph analytics, but you can make data enhancement more powerful if you want to use graph analytics. And to explore the power of graph analytics, I'll hand it over to Jean, who will walk us through this part and followed by a live demo of pre-processing. Over to you, Jean.
Thank you so much. So let's talk graph analytics. There's a very active field of research in graph theory that has helped the development of numerous graph algorithms that help make sense of collected data. And today, popular graph database vendors such as Neo4j, Memgraph, or AWS are embedding these capabilities into dedicated frameworks. You may know some of these frameworks, and Shraddha called them out just earlier. We're talking about Neptune Analytics, Neo4j GDS, and Memgraph MAGE. These frameworks are not a hard requirement to use the pre-processing feature in Linkurious Enterprise, but because you can get value out of simple graph queries. This being said, there's value in leveraging advanced graph analytics, and in this section of the presentation, we're going to get to walk you through some of the popular graph algorithms so that you can get a feel for the value that's out there and can start thinking about whether it makes sense to apply that within your own use cases. So let's get started. First, here is a bit of an overview of the various types of algorithms that are associated with graph analytics. So for example, you have pathfinding algorithms. So maybe you want to know if one of your clients is indirectly connected to a politically exposed person. That's where pathfinding comes in. There are also centrality-based algorithms, and it can come in handy if, for example, you want to know who is the leader of a particular group of persons. Another type of algorithm is the community detection algorithm, and maybe you want to know if a particular money launderer is part of a larger network. Then you have link prediction algorithms. Maybe you want to know if two persons are likely to know each other. Then you have the algorithms dedicated to identify similarities. So maybe you have identified two persons, and you want to know if they're actually similar. If this fraudulent person, for example, is similar to that other new person. And then you have graph embeddings, which are all about turning contextual data, graph data, into machine learning friendly input, aka into vector representations. So these are the types of algorithms, and in each of these categories, you have a wide range of algorithms. So, for example, in terms of pathfinding, the shortest path algorithm is very popular. In terms of centrality, you have the PageRank algorithm. In terms of detection of communities, you have the connected components algorithm, and you can see some of the other popular algorithms. The point I want to make there is really that making sense of graph data is a journey, and our clients, they typically start on the bottom left corner with graph visualization. You start by pushing your data into Linkurious Enterprise, and then you can search it, visualize it as a graph, and out of the box, very quickly, you're going to get value, and will be, for example, you will be able to accelerate your investigations and to make sure that no matter how complex the context around a particular situation is, you will be able to grasp it. And then the next step is typically to activate alerts and know data enhancement, and do that based on simple graph patterns. And you can get a lot of knowledge out of that. For example, you can detect suspicious patterns. You can also compute some context-based risk scores. And then at this point, maybe you want to start applying graph data science, and then you can further improve the detection of risks and insights based on these graph algorithms that we just discussed. And you can also potentially look into leveraging graph analytics to improve your existing machine learning models. So really, it's a journey, and it's not necessary to become a graph expert, an expert in graph data science to get value out of Linkurious Enterprise and out of the pre-processing step that we are rolling out. So we just discussed the theory of the new feature and of graph analytics. Now it's time to dive into some concrete use cases. And we have prepared for you a few demos, and let's get started with a supply chain use case. So here we are asking, am I exposed to climate risk via my suppliers? And first, something important to consider is that there are really two ways to approach risk. There's the entity-centric approach, and then there's the network-centric approach to scoring. In the entity-centric approach, you look at a particular entity and its characteristics, and you use that to assess it. So you look at your supplier, the turnover, number of employees, where it's located, and based on that, you make a judgment in terms of, is there a risk of default there. And then the network-centric approach, it's different. It's all about looking at the entity's network and using that to assess it. So it's not just looking at this entity and its characteristics, but looking at the suppliers, and are these suppliers at risk, and as a result, are they causing a risk in my direct supply? So really two approaches to scoring and analyzing risk. So here is an example of applying network-centric scoring to an ESG use case. So we have a query here that looks at the suppliers of a company and the climate risk nodes that they are connected to. What we do is that we sum the various climate risks, and it's all aggregated into a synthetic score. And this score, it leverages an understanding of the connections to surface indirect risks that would be overlooked if we are too focused on the entity itself and its direct suppliers. So you can see the query on the right all starts with a company, and we are traversing the graph to identify suppliers. The suppliers have sites that are connected to locations, and sometimes these locations are connected to climate risks. And when we have that sort of situation, then we add up all the risks associated with these locations into an aggregated risk property, and we assign this score to the starting company. So that's what really a query in pre-processing can look like. And then this can be applied in practice in a number of ways. First, the new property can be used to color the nodes or to size them to help with the visual analysis of the data. The new property can also just be used in an alert. So, for example, you want to flag every company that have a risk score above a certain threshold. That's easy to do. And then a point that I want to make is that we focus on the network-based approach to risk score, but for sure it can be combined with an entity-centric approach. By combining these two types of signal into a synthetic score, you get a more robust understanding of risk. So now let's switch to a bit of a demo. So first, looking at the Linkurious Enterprise UI, here we are looking at an alert, an ESG alert. We see that there's a data pre-processing step here, and in that data pre-processing step, we compute the risk score. So I'm going to go ahead and click on Edit, and here you can see the query that we looked at previously together. So that's why you type the query in your pre-processing steps, then you can hit save, and then you can just figure out the frequency of the alert. You can enable or not enable, and you can save and run or simply save the alert. And once it's done, then the pre-processing step will start to be computed. Okay. Now switching to visualization. So here we have computed we have used that pre-processing step and we have computed the risk score. And we can see, for example, that Tesco Superstore here is a company. It indeed has, so this will be more relevant. Here we have Sainsbury's. It has an aggregated risk score of 7 as a result of the pre-processing step. And that information, we can display that. For example, we can use the node sizing. Maybe we want to size the nodes based on that property. So we are doing just that. And that can help me see very quickly that that company, Scott Mead, apparently has an aggregated risk score that's much greater than the other companies. So that's it for a first quick demo. And now let's go back to the deck. Okay, so that's one first use case. Now let's talk about a second use case. This time we want to figure out if some of our clients are actually present in sanctions list. So here we are once again using the pre-processing feature, and we are combining that with an external API, the sanctions.io API, to do some sanctions cleaning. So you can see the query on the right. What we are doing there is that we have a query that scans a database, looks for clients, for persons, and then look at these persons via the sanctions.io API to identify if they are sanctioned entities. So we can look at the query. Here we identify the persons. Here we pass a query to the sanctions.io API, and then there we see that when we have a match, we turn the asMatch property into yes and add a timestamp. And when we don't have a match, we just turn that asMatch property to no, and once again add a timestamp. And this way, this approach of coding that external API is really a very pragmatic way to implement the sanctions scanning capability in Linkurious Enterprise. And then on top of that, you can, for example, create an alert. You can, for entities that have been flagged as being present in a sanctions list, you can also display that data visually within the interface and more. So that's it for second example. Now let's talk about another example. This time we are going to focus on node embeddings and machine learning. And we'll talk about a very simple use case. We want to use context to help make recommendations in terms of friends. So here we are going to be computing a graph embedding, and we will use that to improve a machine learning model. So the first step of doing that is to create a graph prediction using the Neo4j GDS library. So we can see what it looks like. We have a query on the right where we use that pattern of persons that know other persons, and we use it to create a projection. That graph projection will be used in the next step. And in that next step, we use the fast random projection or FastRP to create a node embedding property. So what FastRP does is that it turns the graph context of each node into a vector that can then be leveraged via traditional machine learning techniques. So this is really a way to combine machine learning and graph analytics and to use that to make more accurate predictions. And once again, you can see on the right what the particular pre-processing step looks like. And here we are basically calling the FastRP algorithm and applying that to all persons graph that we created earlier out of a projection. So that's the code for that. And then this new property, it's added to the graph database via Linkurious Enterprise. And then it can be leveraged, as I mentioned earlier, as a feature in a machine learning model. And the machine learning model is going to use that new graph feature to improve its accuracy. On the right, you have a bit of a schema that represents another use case where we have credit requests that are rolling in. And these credit requests are pushed to a data science platform that uses a machine learning model to identify the risky requests and basically screen them out. And the same information is also pushed in a graph backend with Linkurious Enterprise and Neo4j for investigations of the risky requests. So you have something that's more akin to a real-time workflow and another workflow that's more post-hoc once the risky requests have been identified. Okay, so that's the starting situation. And then we apply the pre-processing step. At this point, Linkurious Enterprise is going to be used to compute some graph metrics. These graph metrics are computed and saved in the graph database. and they are pushed in the machine learning model. The machine learning model is enriched via the graph metrics that are stored in the graph database, and these graph metrics can be used to better filter the risky requests. So this would be really an example of integrating graph analytics and machine learning with the help of the pre-processing step in Linkurious. Okay. Another use case. This time we want to know if a client, a new client, is actually part of a network of fraudsters. And once again, we are going to be using the pre-processing step to figure that out together with graph analytics. So at first, we are going to tag risky clients with a new label, a new label, I guess, which is risky client. And this will be used in the upcoming steps of the process to identify those risky clients. You can see the code on the right. So basically, when we have clients with a risk score above that particular threshold, then we apply a label which is risky client. So fairly easy. Then we have a second pre-processing step where we are creating a graph projection. This time it's a bit more sophisticated than earlier. We are creating a projection where we have people that are interconnected when they share personally identifying information. And then we use this projection to run the weakly connected component algorithm to identify communities. So you can see the code for that. So here we have a graph query that identifies people that are connected across a shared IP address, a shared email, a shared address, and more. Okay, and here we see that we have created that projection, I guess. And here we are applying the weakly connected component algorithm to this virtual graph. Please note that we are using a seed property there. So that seed property is going to help have stable IDs for the various communities instead of changing the IDs of these communities every time the algorithm is executed. Okay, so that's for the second step. And then all of this comes together in the final step where we are creating an alert model. And this model, it leverages everything that we have done in the previous steps. And it's going to help identify suspicious communities, as in communities that contain multiple risky clients. Okay, so let's look at the alert. So we are identifying communities. And then within this, within these communities, we are basically counting the number of risky clients and normal clients. When we have a particular ratio of risky clients within the community, then we are creating a match and basically generating an alert. Please note that here we are using the community as the target of the alert, and that helps avoid creating a new alert every time a new node is added to the community, and it helps as a result make sure that the alerts are very relevant. Okay, so let's switch now to a demo of that. So clicking on alerts here. So this is the alert that we have just seen. So we can see the pre-processing step there. The step one, where we basically try to identify the risky clients and tag them. And then the step two, where we were creating a virtual graph and then computing communities on this virtual graph. And then all of that comes together in this alert, and we have seen that alert previously. and then you simply choose the frequency, and you can save and run the alerts. Okay, so that's what it looks like, I guess, from the perspective of a data scientist. And then as an end user, I would simply connect to the alerts dashboard, and I can see the cases that have been flagged by this particular alert. And I can click on one such case. It opens up a visualization interface. I can zoom in, and I can see that we have 1, 2, 3, 4, I guess 5, and maybe 6 different clients, and they are all interconnected across PII. So here we have Bernetta and Danielle that are sharing an address. Here Danielle and numbers are connected across a phone number. Okay, so far so good. I mean, it's a bit weird that all of these people are interconnected, but what's interesting to me is that within that community, we have 1 risky client, 2 risky clients, and I guess 3 risky clients. All of those clients have a high risk score. So I guess this one has, a very high risk score, and that's the reason why a case has been created. We have a community with large number of risky clients, and as such, there's a decent chance that these people that are interconnected across PI are actually part of a large fraud networks. And the pre-processing steps, the use of Graph Analytics, and the alerts capabilities of Linkurious Enterprise have just helped me detect that and then conduct a quick investigation to make a decision. So that's it in terms of demo. Let's go back to the presentation now. And Shraddha, I will let you do a quick wrap up.
Yeah, so now it's time for wrap up. And to wrap things up, here's a quick overview of what we have covered today with pre-processing feature in Linkurious Enterprise. First of all, pre-processing is now live, and you can start using it right away to automate your graph analysis. Pre-processing is a way to enhance your data and lets you turn graph queries into automated processes, helping you enhance, enrich data seamlessly, reducing the amount of manual effort, of course. Also, this feature automatically enriches and updates your data as it enters the graph, ensuring your insights are always up to date and accurate. It can be used in multiple use cases, as you heard with Jean, either compute risk scores or enriching your data with external APIs, normalizing data, and much more. So please take advantage of this powerful feature to streamline your operations, enhance data continuously, and accelerate your decision-making process. Thank you for your time today, and we look forward to seeing how you will leverage this new feature in your own workflows. And I guess it's now time for Q&A. Over to you, Catherine.
Yeah, it is indeed. Thank you, Shraddha. Thank you, Jean. So I see we already have some questions that have come into the Q&A panel. If you still have some questions, it's not too late to drop those in, but we can already start with a first question. Thank you for this presentation. Would it be possible to run the pre-processing steps on demand instead of scheduling every hour?
I guess you can, do save and run when you are creating or interacting with an alert. So that would be one way to run on demand.
Perfect. Thanks, Jean. A next question. Do you recommend using a graph algorithm library like Neo4j GDS with data pre-processing?
Definitely something that I would recommend looking into. Maybe not, start from the get-go with that. But if you want, to get the most out of pre-processing and alerts, for sure, it's interesting to look into Graph Analytics and apply that.
All right, perfect. Thank you. So let's see, we have a next question. How can I bring third-party data into pre-processing in Linkurious?
So we have seen one such example where via the pre-processing step, we are calling an external API, and we use that, I guess it was the Sanctions.io API, and then it's being used to enrich the data. You could do the same thing with, Google Maps in order to add that long coordinates to locations, or you could call, another third-party data provider. So it's very easy to do this sort of workflow, yes.
Perfect, thank you. So we have a couple of more. Does using data pre-processing permanently modify my data?
It does. So the whole point is really to make modifications to the data, and these modifications they're added, I guess, to the underlying graph database. Correct.
Okay, perfect. And we have one last question. So this one is, can you use centrality scoring when doing a manual investigation for exploring a complex case?
Yes, for sure. So you can use the pre-processing step and compute centrality metrics across the entire graph. So effectively, you would use something like the PageRank algorithm, I guess, to compute the centrality of all the nodes. And then that's a new property, and when you are conducting an investigation, you can leverage that. Maybe you can size or color the nodes based on this. So that's one particular workflow that will leverage the pre-processing step. Another approach is to use a query and just run the same sort of algorithm, I guess, but on a specific subset on a bunch of nodes that you are looking at within the context of an investigation, and then you compute the centrality based on this subgraph and just those nodes. So these are two approaches, and both can be done with linkers.
All right, great, thank you. So I think that's all the questions we have for today. If you think of any questions afterwards, you can also email us, of course. We'll be sending the recording out shortly, so keep an eye out for that. And otherwise, thank you everyone for joining, and we'll see you at the next webinar.
Thank you so much.